Rahman Rahim. Now we will be learning the solution of the first question of exercise 1.1. So this is the question which says that which of the following sets have closure property with respect to addition and multiplication. These are four parts of this question. The first is having the set 0, only one member, which is member is 0. The second set is having only one member and that member is 1. The third set is 0 and -1, it is having two members, while the fourth set is having the two members which are 1 and -1. So for each individual part we have to find the closure property with respect to addition as well as with respect to multiplication. Both of these things will be verified for all of these questions or all of these parts. So for the first part, let's proceed ahead. We have the first part and this is 1, which is 0, set 0. So we'll be looking into this thing, first part, and we have to see first part of the exercise 1.1. Question is first and the part is first part. Part 1. And what is that? That we have the set 0, which is having only one member, which is 0. So this set is having a certain number of elements, which is 0. So never consider it to be an empty set, because empty set is not having any member including 0 as well. But this is not an empty set, it is having one member, which is 0. Anyhow, so for we have to verify two properties. What are those properties? First is the property of addition for addition. So closure property with respect to addition. So we'll be doing the process for the closure property with respect to addition. So let's see how this can be done. So we are having one member which is 0, and also we have to find the its relation to the closure property with respect to addition. So for addition is having the plus sign, so you have to use this plus sign, and now you have to draw the two lines which is on the right side of the plus sign and toward the downside of the plus line. One is vertical while the other is horizontal. Now what you will be doing, that you have to look into this set and you have to check that how many are the entries of this set and what are those entries. For example, this set is having only one entry and that is 0. So you must write this 0 horizontally. This 0 must be written horizontally towards the right of the plus sign. Then next is, which is next entry? There is no other entry, so there is no need towards the right side. So horizontal side is complete. So left to right process is complete. You have to write all of the entries which are given in this set in the horizontal process, and then all of these horizontal blocks will be filled. And now similar process will be done for the vertical procedure. What is going to be done? That you have to write all of these entries vertically as well. For example, first entry is 0. Next is, which is next entry? There is no other entry. So only 0. Now, what you will be doing, that you have to consider this block or this box. You have to consider this box, which is for the output of these two. For example, since we are going to apply the plus operation, so you have to use the plus operation in this box. How will we using? You will be using it through, because since this is on the right hand side, first member is 0, so this will be written in this box as 0. Then on the vertical side, it is again first member is 0, so this is 0. So 0 plus 0. Why plus? Because the plus operation has to be performed here. So you have got 0 plus 0. So 0 plus 0 is equal to, basically it is equal to 0. This is equal to 0. So you will write 0 at this place. Now since there is no other box to be filled, because all of the results have been taken, therefore now you will be seeing that what is the result and what's its relation with the given set. For example, this is the resultant, which is the output of the plus operation of all of the members. This is only one output, and if you check this output into this set, is this entry is existing in this given set? Yes, it is found in this set. Therefore you can say that the 0 means this given entry is belonging to the given set. So you will write 0 belongs to, what is the sign of the belongs to? This sign, epsilon type sign. This is belongs to, 0 belongs to the given set. Which is the set? 0. So you can say that there is no other result, therefore you will be considering this thing, and you will be writing the given set. Since all of the members are found in this set, so the given set obeys the closure property of addition. So this set obeys the closure property of addition, or with respect to addition, you may write it as with respect to addition. So this was your first part, the first answer of the first part. Now we'll be trying to get the second answer of this first part, means for the multiplication. Now you will be giving the heading for the multiplication. So now for multiplication. So this is the heading for multiplication now. So you will be doing the similar type of the process which you have already done. What that you have to do, that you have to use the cross sign here, because for multiplication you are doing the calculation for the multiplication. So cross and then this thing, and now you have to write all of the entries. This is only one entry, so you have written it horizontally, and now you will be writing all of the entries vertically as well, so write all of the entries vertically. So since this was 0, and this is the box where you will be writing the output. In this box you will be writing the output. And what is the output? Means 0 cross 0. What is 0 cross 0? 0 cross 0, or 0 multiplied to 0 is equal to, what is this? This is equal to 0. So you will be writing this 0 at this place. So you have to write at this place 0. Now again the similar situation has been arisen. What is that situation? That whatever we had done in the previous section about the addition, the similar thing is happening with the multiplication. Again similar thing has been produced. So you can say that 0 belongs to the given set, because the result is 0, so you may say that the 0 is belonging to the given set. So you will write again 0 belongs to the given set. So you can say that, what you can say, therefore you can say, thus the given set obeys the closure property of with respect to multiplication. Now you can see here that this set is obeying both of these properties, the closure property with respect to addition, as well as it is obeying the closure property with respect to multiplication. Both of these are verified, have been confirmed. So you have to write the result at the last. So what is that result? You have to write the result. Let's see what's the result. The result is the given set obeys the closure property of with respect to addition as well as multiplication, because both of these properties have been verified for this set. So this was the part 1 of the question 1. I hope you have got the understanding of this. But now, because I am willing that you must do these questions with very ease. So how this ease can be produced, that if I can tell you the different method. For that I have to tell you the main understanding of this question. So you can see, again I am going to write it. So again, let's see, because if I'm going to tell you the different method or different methodology, then that will be more better for you. It will be better for your understanding. You will be able to solve all types of questions. So actually the thing is that, so now we are going to use the second method, and in this method more thing is that I'll be giving you the explanation that what the question has been asked. So this is only 0 member or whatever it is. So what is meant by the closure property? Closure property means that if you are adding or multiplying any two members of the given set, then those members, the resultant members, will also be the members of the given set. For example, let me tell you that, for example, if you are having natural numbers, let us consider that if you are having natural numbers, what are these natural numbers? 1, 2, 3, 4, 5, 6, 7 and so on. These are unlimited natural numbers up to 1000, million, billion, trillion and so on. Infinitely these are going up to infinity. If you try to add any two numbers, for example 3 and 4, what will be the result if you are going to add 3 and 4? The result is 7. So you can see that the result 7 is also included in this set, because this is 1, 2, 3, 4, 5, 6, 7, 8, because these are going to unlimited toward the infinity. So 7 is also included. And now if you are going to add 7 of this set to 10,000, any number randomly 10,000, then this will be, what will be this? This will be 10,007. So this 10,007 is also included in this set, because this set is unlimited and this is having this member as well. So this the natural set, this natural set is obeying the closure property of addition. Closure means it has been closed into this set. Every result has been closed. So similar situation is being arisen here, that if you check your given question, your given data, and what is that data? This is 0, only 0, one member has been given here. So only one member, which is 0. So what you will be doing? Let's see. So if you are going to add any member of this set, but you know that this is only one member and which is 0. If you are going to add 0 with exactly to it, as because there is no other member, so those can't be added with each other. So this is 0 plus 0 will be equivalent to 0, and you can see that this 0 is included in this set. Therefore, this set, the given set, is obeying the closure property of addition. Okay, so you can simply write as 0 plus 0 is equal to 0, which belongs to the given set, which is 0. So what is meant by this? The given set obeys the closure property with respect to addition. So this was the second method. You can use it, but I'll prefer the previous one which I have told you. You must use that. So in the next parts, part 2, part 3, part 4, I'll be using that method. But practically both are these are similar things. There's no issue. There's no difference between both of these. Any of will be moving ahead. So we are moving towards question 2, part 2 of this question. So what is saying part 2? According to part 2, it is having only one member, and that is 1. So at first we'll be doing for the closure property of addition. So for this, let's see. I hope you remember the procedure, because this is related to addition. So plus sign is important here. So addition plus, and then you will be drawing the lines, vertical line and horizontal line, and you will be writing all of the entries horizontally, all of the entries of this set. What are the all of these entries? Only 1. This is 1. So you have to write 1 here. So 1. What is next entry of this set? There is no next entry, so there is no need to write it. Next is for the vertical. So if you are going to write these entries with the vertical, so only one entry, which is 1, so you have written it. And this box which is now I'm showing it white, this is related to the output of these entries. These entries will be added. Added means, because this is plus sign, that's why these entries will be added with each other. So after addition, you will be writing the result. So let's write the result. That this is actually upward is, this is 1, while on the left side it is 1 input. Both inputs are 1 and 1. Upward input and left side input is 1 and 1. So you will write 1 plus 1 here. 1 plus 1. 1 plus 1. And what is this? Actually this is 2. It is equal to 2. Now you can see here that this 2, can you see that this 2 is not included in the given set? Because the given set is 1, it is having only entry 1, and the sum of these 1 and 1 is equal to 2, which is out of this set, because this 2 is not included in this set. So this is out of this set. Therefore the given set is not obeying the closure property of addition, because the result is outside of this set. So you can write, what you can write, that the given set, as first you have to write the as 2 does not belong to the given set, you have to write as to does not belong. So this is the sign of belonging, and if you are going to write the does not belong, so you have to write an oblique line, you have to draw an oblique line out. So this means does not belong to the given set. What is that given set? This is entry 1. So therefore the given set does not obey the closure property of addition. So this is your first answer of part 2. Now we'll be moving ahead and we'll be looking next for the multiplication, for closure property with respect to multiplication. You will be giving the heading. What will be the heading for the closure property with respect to multiplication? For closure property with respect to multiplication. So you already know the procedure. What is the procedure? That you have to write the sign, the symbol of cross, because multiply is concerned here. And then you have to write all of the entries horizontally, which is only one entry, which is 1. And then all of the entries vertically, which is only one entry, which is 1. So since this is cross, so in the box of the output, this is the output box. I am showing it white. So in this box you will be writing the result. So this is 1 cross 1, because both are being multiplied with each other. 1 cross 1, which is equal to 2. Sorry, which is equal to 1. 1 cross 1 is equal to 1. So you have to check that this result, which is 1, is this included in the given set or does not include, is not related to that. So if you check this entry 1, then this entry 1 is included in the given set, is contained in the given set, and this is only one output, and this one output is not out of this set, but it is included in this. This is inside this set. Therefore the given set is obeying the closure property of multiplication. Therefore you will be writing, what you have to write, that the given set let me write here. So it means that you have to write the detail. At first you have to write the detail. So what is that detail? That since 1, the output, or you may also write it this, 1 cross 1 is equal to 1, which is belonging to the given set, which is 1. So what does this mean? It means that the given set obeys the closure property of multiplication. A closure property with respect to multiplication. Therefore, for part 2, we have found that both of the part 2 set is obeying the closure property of multiplication, but it is not obeying the closure property with respect to, what is that, with respect to addition. So you can see here that the given set here, at first we had got this result, the given set does not obey the closure property of addition, but for multiplication the given set obeys the closure property of with respect to multiplication. Therefore you will be writing the result, and what will be the result? Let's write the result. So the result is the given set obeys the closure property with respect to addition, but does not obey the closure property with respect to set obeys the closure property with respect to does not obey, sorry, the set does not obey, because previous for addition it is not obeying, so does not obey the closure property with respect to addition, but obeys the closure property with respect to multiplication. So this was the end result of this question 1 part 2. This is the final answer for part 2. Now for part 3. Part 3 will be bit difficult for you. Let's see how it is difficult, and but it is easy if you have paid attention to the previous 2 parts. Then question part 3 will also be very, very easy for you. Let's see how it can be. So part 3 is having a set with 2 members. First member is 0, and while second member is -1. So 0 and -1, 2 members. So if you write, so at first you have to calculate for addition. You have to give the heading for addition. So what is the procedure? I have already told you that at first since this is for addition, therefore you will write the sign of sum, means addition, and then you have to draw the vertical and horizontal lines across it. And now you have to write all of the entries of this given set horizontally in the right direction of this plus sign. So this is first entry is 0, while the second entry is, first entry is 0, while second entry is -1. So these are 2 entries. There is no third entry, and you have written on the right side, while now you have to write both of these entries below the plus sign as well. So first entry is 0, while the second entry is -1. Now you have 4 output boxes. This is first output box, second, third, and fourth. 4 output boxes. What you can do with these? For the first box, you can see that this first box is related to the upper output, which is 0, while the left side input is, upper output is 0, while the left input is also 0. So, and the operation is plus operation, means addition operation. Therefore, you have to add both of these zeros in this set, in this box. So this is 0 plus 0, which is equal to 0. So this is the output in this box. So what is the output in this box? 0. The entry 0 is the output in this box. So this is 0. 0 is the output. Now for the next box, which is located rightwards, for this you can see that the input, upper input is -1, while the left input, which was the main member of the set, which is 0. So 0 and -1 will be added in this box. So this is -1, first member is -1, while plus, why? Because we are using for the addition. So -1 plus 0. What is the result for -1 plus 0? What is that result? The result is -1 plus 0 is equal to -1. So this is the output. Now for the third, this is this box. For the third box, we have to see that what are the inputs. For the third box, we have the input located in the upper direction, which is 0, actual main input, while toward the left side it is -1. These are two inputs. So you have to add these two inputs, means 0 and -1. You will be adding 0 to 0 and -1. So just add 0 and -1. So this is 0 plus -1. And you very well know that this will be, resultant will be -1. Why? Because I am doing on the rough side that 0 plus -1 is equal to 0 plus minus is -1. So 0 minus 1 is -1. That's why we have written at this place -1. Now for the last fourth box, we have to give the result. So in the fourth box you can see that it is having the upper input, which is equal to -1, while the leftwards input, left side input, this is -1. Both are -1. Therefore you will be adding both of these entries, -1 and -1, in this box. So if you are going to add these two entries, -1 and -1, so first is -1, while you have to add plus, again -1, -1 plus -1. So on the rough side I am going to get the result of these. So -1 plus -1 can be written, this is first is -1, and both of these, this is minus and these plus, both will be treated and they will be generating minus plus. When they combine, they generate minus, so into 1. So -1 minus 1 is equal to -1 minus 1 is equal to -2. Therefore your result is -2 for this box. So you will be writing -2 in this box. So the result is -2. Now we have to analyze this. How we can analyze that? If we look into the details of all of these outputs, first output is this 0, this is the first output, the second output is -1, third output is -1, fourth output is -2. Do you find any of them which is not included in the given set? If you analyze first, if you check the first, then 0 is included in the given set, so there is no problem. So for this 0, the set will be obeying the closure property of addition. For the next is -1, the next output is -1. -1 is also included in this set. The third entry is -1 again. This is also included in this set. While for the fourth entry -2, we have found a member which is not included in this set. -2 is not included. Now what the solution? That since -2 is not included, this is out of this set. Therefore, we have to find only one member which is not included in this. If you have found only one member or more than that, minimum one member. If you have found it, then the given set will not be obeying the closure property. Therefore, we will be saying, what we will be saying? That the given set does not obey the closure property of addition or with respect to addition. So let's see, as -2 does not belong to the given set. This is the sign for the does not belong to the given set. What is that set? 0 and -1. Therefore, what is that? Therefore, the given set does not obey the closure property with respect to addition. Now we will proceed for the second thing, and which is multiplication. We will be checking for the multiplication as well. In order to check for the multiplication, we have to give the heading for multiplication. So you are already aware to that procedure. What is that procedure? That at first you have to write the multiply sign, then these lines, and then you have to write all of the members on the right side. Only 2 members are here, and then you have to write all of the members below the cross sign as well with the same arrangement. It is better that the arrangement is same. You can change the arrangement, but at the current level, I suggest you that you must not change the arrangement. Anyhow, so at here you can see that for multiplication, so this is in the first box, you have to multiply 2 things. First, upper is 0, while the left side is left input is 0. So 0 cross 0, or 0 multiplied to 0. What is the result of 0 cross 0? Is equal to 0. While the next box, it is having the input, upper input is -1, while the left side input is again 0. So these 2 inputs are going to be taken here. Therefore, so 0 and -1, the resultant is -1. Next is this third box. In the third box, you see that the upper input is 0, while the left input is -1. Therefore, 0 and -1 will be equal to -1. The result will be -1. And in this last box, fourth box, you can see that the upper input is -1, while the left input is -1. Both are -1. Therefore, -1 multiplied to -1. Both will be multiplied to each other. And now here is the issue. That what is that issue? That if you are going to multiply -1 with -1, what is the result? Negative and negative will be combined during multiplication. They are combined and they become plus sign. So these 2 negatives will be converted into plus sign, +1. So 1 and 1 is 1 multiplied 1 is 1, while this is plus. Or you may write it simply as 1. So this is +1 or simply 1. Okay, let's write it as +1. This is your own choice. Either you write only 1 or +1. The results will be same. So let's write it as plus 1. Now let's analyze. If you pay attention to all of these 4 results in an arrangement, then what happens? Let's see the first result, which was 0, this 0. If you check this 0 into the given set, so you find that yes, it is included in this set. It is included in this set. Therefore, there is no problem. So still the set is obeying the closure property of multiplication. Now for the next entry, next result, this is -1. So let you check this -1 into the given set. Yes, it is also included in the given set. -1 is included here. So still the set is obeying the closure property of multiplication. Now next is again -1, and -1 has been verified that it is included in this set. Therefore no problem. So the final is +1. If you check here in this set, then there is no +1 because this set is having -1, not +1. So this +1, the result +1 is not included in the given set. This is out of this set. Therefore, due to this +1, the given set is not obeying the closure property of multiplication, because we have to find only one entry. If we have found only one entry, then that will be not obeying the closure property of multiplication. Therefore, we'll be writing what we have to write now as +1 or simply 1, as +1 does not belong to the given set. What is this given set? 0 and -1. Therefore, the given set does not obey the closure property with respect to multiplication. Now we have got 2 results. First is the result which is saying that the given set does not obey the closure property with respect to addition, while the second result is saying that the given set does not obey the closure property with respect to multiplication. So for both of these, means for addition as well as multiplication, the given set is not obeying the closure property. Hence we can write the result. What is that result? Let's see. The given set does not obey the closure property with respect to addition as well as multiplication. The given set doesn't obey or is not obeying the closure property with respect to addition as well as multiplication. This is the final answer. Now we have to solve the fourth part. What is that fourth part? Fourth part says that set has 2 members, which is 1 and -1. Only 2 members here. So at first we'll be solving for the addition. For this purpose, you're already aware that we have to use the sign of plus sign, and then these two lines, and we have two entries here of because we have two elements, 1 and -1. So we have to write two entries in the horizontal as well as two entries in the vertical. What are those entries? 1 and -1. So again you have to write 1 and -1. What will be the results? So for the results, we have to see that this box is related to the upper input and left input, which are both 1 and 1. So result is 1 plus 1, because this is plus operation. So this is 1 plus 1, which is equal to 2. Next box, this is having the upper input, which is -1, while the left input is 1. So -1 and 1. -1 and 1 means -1 plus 1. You can see here that both will be cancelled with each other. Result is 0. So second is result 0. While for the third box is having the input, upper input, which is 1, while the vertical input, which is -1. So 1 and -1 means 1 minus 1, or 1 plus into -1, which is equal to 1 minus 1, means this is on the rough side. I am doing this so that you can understand. 1 plus -1, both of these have been cancelled, or you may plus minus is minus, so 1 minus 1 is equal to 0. So result is 0. Therefore, you will be writing 1 minus 1 is equal to 0 here. So result is 0. Next, for the fourth box, you can see that the input of the horizontal is -1, while the vertical input is again -1. So both of these will be added. So if you see it, then this is -1 and again plus -1. Both of these have been added with each other. -1 and plus minus is minus, again -1. So -1 minus 1 is -2. Therefore you have to write -2 in this box. Therefore you need to write -2, or you may write the complete procedure as well. Any of this is -2. You may write the procedures, complete procedures. For example, in the upper box I have written the complete procedure -1 plus 1 and is equal to 0. You may directly write the answers. If you have so much grip on this, then you may write the direct results here. Anyhow, after obtaining the outputs, we have 4 outputs. We have to check now these inputs. Now, for example, this is first input, which is 2. If you check it into this given set, then 2 is not included into this set. There is not any 2 found here. So since 2 is not found here, therefore we don't need to confirm the remaining results as well, because we have to find only one entry which is not included. Anyhow, you can check the remaining entries as well, but you need to find any one entry which is not included, and when something is found which is not included in this, then that will be the given set will be not obeying the closure property with respect to addition. So since this 2 is not included in this set, therefore it is not obeying the given set is not obeying the closure property with respect to addition. But not only this case is not only with 2, but this 0 is also not included in this, and this result 0 is also not included. All of the 4 results are not included into this set. Anyhow, due to these results, the given set is not obeying the property of the closure property of addition. So as you may write any one of these or you may write all of these, but it is more better that you are writing all of these. First entry is 2 does not belong to the given set, and again the second entry is 0, second result is 0 is also not belonging to the given set, 1 and minus 1. The third entry is again 0, that is has already been written, while fourth entry is minus 2 is also not belonging to the given set. Therefore you can say that the given set does not obey the closure property of addition. The given set does not obey the closure property of addition. So this is the result for the addition. Now we will be looking into the result for the multiplication. So you have to give the heading for the multiplication. For closure property with respect to multiplication. You are very well aware to the procedure. What will be that procedure? That you have to use the sign of multiplication. What is the sign of multiplication? This is cross sign, and then these lines. And then only two entries, 1 and minus 1, and again in the vertical you will be writing 1 and minus 1. So if you are going to get the results, that first entry is first box is having the input which is 1, the upper input, or that is called as the row input, is 1, while the column input is also 1. 1 cross 1 means 1 multiplied 1. So 1 multiplied to 1. So you have 1 multiplied to 1. Do you know what is result of 1 cross 1? Yes, 1 cross 1 is equal to 1. Then the next column is next box is, it is related to the row input which is -1, while the column input which is equal to 1. Therefore -1 and 1 will be multiplied to each other. If you multiply -1 and 1, -1 multiplied to 1, so your result will be, what is that result? If you are going to multiply -1 to 1, then what is the result? Minus, and 1 is 1, therefore this is -1. So this result will be -1. For the third box, you have the upper entry is 1, while the left entry is -1. Upper input is 1 and the left input is -1. So you have 1 multiplied to -1, or -1 multiplied to 1, which is equal to -1 multiplied to 1. Again you have got -1, because 1 multiplied to -1 is equal to -1. While in the fourth box, this box, the input is, the row input is -1, horizontal row input is -1, while the vertical column input is also -1. So you will be having -1 multiplied to -1, which is equal to, what is that? So -1 on the rough side I am doing here. So negative 1 multiplied to negative 1. So you can see that during multiplication, if two symbols which are negative and negative, if they are going to be multiplied with each other, negative makes a positive. So this is positive plus, and 1 is 1. So you have positive 1, or simply you may write it as positive 1 or only 1. So you have, so this is negative 1 multiplied to negative 1. Let me erase it. So you have negative 1 multiplied to negative 1. It is more better if you are using the brackets, otherwise no problem. So negative is positive, and 1 is 1. So this is positive 1. Now we have to analyze all of these outputs, and we have to try to find that which is that output which is not included in this set. Let's analyze it. Let's see. If you see the first output which is 1, you can see that 1 is included in this set. 1 is found in this set. This is 1. So 1 is found in this set. While the second output is negative 1. Negative 1 is also present in this set. Third is also negative 1. Negative 1 is present in this set. While fourth is positive 1. Positive 1 is also present in this set. So all of these entries are found to be found in this set. They are present in that set. Therefore, since all of the entries are found, there is not a single entry which is not found in this. So since all of these entries are found, therefore the given set obeys the closure property with respect to multiplication. Hence we will be writing the given set obeys the closure property with respect to multiplication. Now let's compare these two results, one for multiplication and the other for the addition. So if we are going to compare these two results, then you can see here that the first is for addition. It is not obeying, does not obey for addition with respect to addition, but it is obeying for the closure property with respect to multiplication. For multiplication it is obeying, while for addition it is not obeying. Therefore, what is the final result? The final result must tell that the given set obeys the closure property with respect to multiplication but does not obey the closure property with respect to addition. So we will write this is result. The given set does not obey. First is because of addition, so does not obey the closure property of addition, but it obeys the closure property with respect to multiplication. So this is the final answer of the part 4 of question 1.
अगर आपके जहन में कोई सवाल उभरता है तो कमेंट सेक्शन में लाजमी लिखें ताकि मैं आइंदा किसी वीडियो में इसका जवाब दे सकूं। और अगर आपको मेरी ये वीडियो पसंद आई है तो लाइक करें, और अगर आपने अभी तक इस चैनल को सब्सक्राइब नहीं किया तो इसको सब्सक्राइब कर लें। शुक्रिया।